I want to touch on perhaps a subtle point when you're using these inverse cancellation laws that we've discussed so far. So we talked about sine of sine inverse of 5. And 5, that is not in the domain of sine inverse of x. In fact, if you went to evaluate sine inverse of 5, this simply is undefined. And it's pretty easy to explain why. Try to figure out what it is. Well, if you set it equal to t, and then change to the original function notation, then you get 5 is sine of t, with t between minus pi over 2 and pi over 2. However, the range of sine of t, the maximum it could be is 1. Sine of t could never be 5, and that's why this is undefined. So this here is undefined. Something a little different happens when you look at a calculation such as the second one, sine inverse of sine of 3 pi over 4. Now, if we conclude that 3 pi over 4 is in the restricted domain of the sine function, then we'll simply be able to write that this is equal to 3 pi over 4. However, unfortunately for us, 3 pi over 4 is not in the restricted domain. 3 pi over 4 is larger than pi over 2. You can see this because if you multiply this by 2 over 2, that's 2 pi over 4. And so 3 pi over 4 is not in the restricted domain of the sine function. So you might be tempted to say that this quantity, sine inverse of sine of 3 pi over 4, is undefined. However, the situation is a little bit different here. In this first example, sine of sine inverse of 5 was undefined because 5 was not in the domain of sine inverse of x. So it's impossible to evaluate sine inverse of 5, and I showed you why in this little example here. Sine inverse of 5 is undefined because if you set it equal to t, you get something that, well, simply cannot happen. However, while 3 pi over 4 is not in the restricted domain of sine, you can still put 3 pi over 4 into the sine function. You can evaluate it. If you wanted to evaluate sine of 3 pi over 4, well, the reference angle is pi over 4, so this is going to be either plus or minus sine of pi over 4. So it's going to be plus or minus root 2 over 2. And in fact, it's going to be positive because 3 pi over 4 is in the second quadrant. So whereas earlier, for our first example, we were unable to evaluate sine inverse of 5, we are able to evaluate sine of 3 pi over 4. It's positive root 2 over 2. And so sine inverse of sine of 3 pi over 4, that's going to be equal to, well, sine of 3 pi over 4 is root 2 over 2, so this is sine inverse of root 2 over 2. And now I can ask myself, okay, what is sine inverse of root 2 over 2? And I'll do that in the same way that I have been doing this. I'll set this equal to t, and I'll change to the original function form. Root 2 over 2 has to be sine of t with t between minus pi over 2 and pi over 2. So I think to myself, what value of t on the right half of the unit circle gives me sine of t is root 2 over 2? Well, the answer is that t is pi over 4. And so sine inverse of sine of 3 pi over 4 actually has an output. It's pi over 4. And the subtle point here is that when you're in this first scenario and you're doing sine of sine inverse, but it could be cosine of cosine inverse as well, and you end up with some number that's not in the domain of the inverse trigonometric function, you get something that's undefined. In the case where you're evaluating sine inverse of sine, or cosine inverse of cosine, or tan inverse of tan, of something here that's not in the restricted domain, then what ends up happening is you get something that's not 3 pi over 4, but it will in fact be defined. So we saw in the second example that this was pi over 4. So the situation is a little bit different for compositions that look like inverse trigonometric function of trigonometric function. Let's do another example. Let's imagine that we're trying to figure out cosine inverse of cosine of minus pi over 6. Now, minus pi over 6 is not in the restricted domain of the cosine function. The restricted domain of the cosine function is 0, pi. However, that does not mean that cosine of minus pi over 6 doesn't exist. In fact, it does. Cosine of minus pi over 6, you can figure this out in a number of different ways. I'll use the fact that cosine is an even function, which means that this is the same thing as cosine of pi over 6, and cosine of pi over 6 is root 3 over 2. And so cosine inverse of cosine of minus pi over 6, that is equal to cosine inverse of, well, cosine of minus pi over 6 is root 3 over 2, so cosine inverse of root 3 over 2. I can set this equal to t and rewrite this inverse function in terms of the original function. Root 3 over 2 is cosine t, and t is between, not minus pi over 2, but 0 and pi. And so I see that t needs to be pi over 6 because that is the t value between 0 and pi for which cosine t is root 3 over 2. And so t is pi over 6. And so I get that cosine inverse of cosine of minus pi over 6 is pi over 6. Contrast that with an example such as the following, cosine of cosine inverse of, let's say, negative 3. This would be undefined because negative 3 is not in the domain of the inverse cosine function.